So this is a demonstration of how the program Go Walk Load Adjust Fast. That's how does it work. It's similar to the previous one, Go Walk Load Adjust, but we're gonna make it adjusting to when it's out of whack a little bit faster. So the same usual thing again. I set all the slope to 32, set the margin to 1, and set the punch to 32. And then I'm all the initial parameters, target position 512, allow areas 1, 4, set torque 4 and 5 start out at 1 also, and TorqueStep is 1, and call init. So call init is similar to before, just repeat all the initialization. First it's high speed, high torque, and it send all servo to go to 512. I have 2 seconds to do that. And then I reduce velocity, but still keep the torque high. So set torque 4 and 5, remember, at 1. So it makes 4 and 5 go soft again. Figure out where it was, target 4 and target 5, so it should be around 512. And then you have the high and the low end for 4, and the high and the low target position for number 5. So I've done that one time. Finish here, it goes to the endless loop. The endless loop is a little bit more complicated than last time. So essentially, when the present position of I4, that means when you disturb it, it's higher than the higher end, high 4, it figure out the gap where you are minus the high 4. And whatever the gap is divided by 2. And it set up the TorqueStep to it, and it increment by that. That means if you are forcing it real fast, when by the time you go through the endless loop, the present position is way off from the high end. So if the bigger the change in the deviation in the position from the target position, the bigger the TorqueStep increase. Okay, so if you move small, the TorqueStep is small. If you move big, the TorqueStep is big. So it depends on how fast can you do the disturbance, and we'll see that in the runtime version of this code. Okay. So that's basically for very large deviation that take care of by this if statement. Okay, but if you are within the target zone and the torque is high, you need to start reducing it, because if it just keep on going high, it go way out of position. So you need to change the torque the other way, reduce the goal torque by 1, change the torque, start reducing it. Basically, if you do this, so this one will, when detect when it's got a whack, and it adjusts back to real stiff. This piece of code, what it does is when you are within range, essentially, you start reducing the torque back to smaller and smaller, so that basically we can play this game again, essentially. So there's a little bit of feedback there. And then so that's done with that one. So let me get a little space here so you can see. But let's take care of when the deviation is big, your TorqueStep is big. When you're within range or getting closer to your target, you start reducing the torque. So you don't want to overshoot too much. If the set torque is bigger than 1, then finally go ahead and set it. Okay. So these are just to set up the TorqueStep properly, the if here to set up the TorqueStep properly. This command here is if the value bigger than 1, and then go ahead and actually set the torque. So this is the actual action to stiffen it or make it go back to the target position. And then similarly, 5, because it's mirror image, it really checking on the lower end of it things because of the mirror image. Basically the same thing. If the gap is big, go ahead, just go 50% of that gap and go on. So go stiff real quick. If the gap, and when you're getting closer and closer to your original position, you start reducing your torque. And so that means what? When you're back there again, you start going soft again, so we can play the game again, essentially. And then here we go again. So if the torque up, if the torque is bigger than 1, go ahead and set the torque. You can see. And then ID equal 4, print the data, ID 5, print data. That's all. And again, I use the virtual remote controller, and I push 1 on it and reset everything. Okay, so let's keep it here so you can see. You see the kind of key logic here. Turn it on. Just download it. You output a program. Oh, well, it's kind of high. I don't really see the numbers. I have the virtual RC here. Now, where'd you go? Okay, there you go. Everybody go to the 5-12 position. So you see the torque limit 4 and 5 accept the 1, and it's within 5, 1, 11, and 12. So I'm going to push 4 on 4 real quick, and then you see it coming back. If I push real fast, it go this more, and then it's coming back. But then I can do it over again. Okay, how about 5? But if you apply slowly, it will stiffen up, and then I cannot go anymore. It won't do that. See, torque limit up to 1023, which is so if you release it, you got slowing down. Okay. So if you go real fast, you can go change more, but you go slow, it will resist. Okay. Kind of interesting concept, huh? You go slow on it, you see, yeah, it would be less. Very slow on it, will be fast. They go fast. Oops, they go fast. You can change more. Okay, and then if I push 1, it reset position again. Fast is coming fast, but you apply slow, you change slow, and then it's stiffen on. You cannot change it either.